Hi, in this video we are going to talk about a few misconceptions that students have in squares, square roots, cubes and cube roots. Now most people think that squares and square roots is a fairly procedural topic and hence not much understanding is required. But that is not the case. A lack of understanding of squares and square roots further on affects the understanding of exponents. So let's have a look at a few examples to better understand the extent of a few misconceptions. So the first question reads, which of the following is both a perfect cube and a perfect square? Option A, 6 cube into 12 cube. Option B, 12 square into 18 square. Option C, 5 square into 2 cube. And option D, it is not possible for a number to be a perfect square and a perfect cube at the same time. So essentially in this question, students were supposed to take each of the options and break them down into their prime factors. If the power of the prime factors is divisible by both 2 and 3, then the number would be both a perfect square and a perfect cube. Then the students were supposed to use the method of elimination to figure out which option is both a perfect cube and a perfect square. So let's have a look at the options. Option A is 6 cube into 12 cube. Now 6 cube into 12 cube when broken down into its prime factors can be written as 2 raised to the power 9 into 3 raised to the power 6. 2 raised to the power 9 into 3 raised to the power 6 is clearly a perfect cube, but it is not a perfect square because 2 is raised to an odd power. Option B is 12 square into 18 square. This when broken down into its prime factors can be written as 2 raised to the power 6 into 3 raised to the power 6. This number clearly is both a perfect square and a perfect cube. It is a perfect square of the number 2 cube into 3 cube and a perfect cube of the number 2 square into 3 square. So this option fits our criteria of being both a perfect square and a perfect cube. The third option is already broken down into its prime factors. It can be clearly seen that the number is neither a perfect square nor a perfect cube. So what do you think students picked to be their answer? Let's have a look at the student data collected. So out of the 2,415 students of class 8 and 9 who attempted this question, around 10% students picked option A, 44% students correctly picked option B to be their answer, an alarming 22% students picked option C and 24% picked option D. So around 24% students believe that it is not possible for a number to be both a perfect square and a perfect cube at the same time. So these students should be shown a few examples of numbers which are both perfect squares and perfect cubes. So for example, the number 64. 64 is the perfect square of 8 and it is also the perfect cube of 4. So 4 cube is equal to 64 and 8 square is equal to 64. Hence, we can show them with the help of a few examples that numbers can be both perfect squares and perfect cubes at the same time. Now, let's have a look at what the 22% students who picked option C to be their answer are thinking. According to these students, 5 square into 2 cube is both a perfect square and a perfect cube. Now 5 square is a perfect square and 2 cube is a perfect cube. So these students think that the product of a perfect square and a perfect cube will result in a number which is both a perfect square and a perfect cube. A way to remediate this would be by telling the students to multiply this number out. Now since this number is neither a perfect square nor a perfect cube, they will not be able to come up with either a square root or a cube root and hence will be able to understand that a number of the form a square into b cube is neither a perfect square nor a perfect cube. Thank you for watching this video.